Okay, good afternoon. So now let us start solving these four problems, five problems actually. There is no lesson here, but that is a title in the book, Problem Solving Using What You Have Learned in the Equations. So far we talked about equations, but the equation was given to you and then you were supposed to use those tricks that you have learned to solve the equation. There are some word problems. They are famous to word problems. It means that you need to read the text. Of course, I have some grammatical errors here. You can correct me if you want to. Thank you. But anyway, you need to read the text to set up the equation yourself, and then the rest of the story would be solving that equation that you already set up. Yes? So that is a difference between the previous one. So you read the text, you need to set up an equation. And then there is nothing that I can teach you that much unless you can just read and be able to set up the equation. But there are some things that might be I can help. So for example, let us consider on this problem, find a number such that, I would definitely recommend you to read it at least 2 times. Okay, just read it first. Find a number such that 3/8 of the number minus 1/2 of it is 14 less than the 3/4 of the number. Okay, so you need to read this and try to set up that equation. So this is why I'm saying that please read the question first. There are problems, I will publish it again in your book. So here I want to find a number. So if I want to solve this problem, I would solve it in this way. I would say that let x be the missing number. Okay, so because I am introducing a variable which is not in the problem, you do not see any x in the problem. I want to play with x. It doesn't matter if you use x, but usually we use x. I would say that my goal is to find a number. So I don't know what that number is. Let me myself call it x. And then try to read that one. We want to find x such that 3/8 of that number. What does it mean? 3/8 of that number minus 1/2 of it minus 1/2 of it, yes, is 14 less than 3/4 of the number. So it means that if you have 3/4 of that number, this number is equal to 14 less than this number. Yes? So that's it. So you see, you need to read it and be able to write this equation yourself. So let me read it again. We want to find a number, so I give it a name, x. Let's assume that x is the missing number. But then by reading this, 3/8 of the number is this one, 3/8 of that number, minus 1/2 of that number, minus 1/2 of that number is less than 3/4, is 14 less than 3/4 of the number. Yes? 3/4 of the number is this one, 14 less than the quarter is this one. So it means that if you do this and if you do this, according to the problem, they are supposed to be equal. Any questions so far? And then if you are able to set up this equation in a correct way, then the problem becomes probably easy for you if you have done your homework fine. You see that you have an equation with 3 here denominators. So I have to get rid of the denominators by multiplying everything by a suitable number. So what would be that suitable number? It's clear. It is 8. So you multiply this by 8. But then, of course, you have a lot of experience now. Hopefully you can do it fast. So I go up here. So if I multiply 8 by there, I told you do not multiply it by the numerator. The whole point is to simplify. So this one and that one are simplified. 1 is left. So I multiply it there. It becomes 3x. But then I multiply 8 here. 2 and 8 are simplified. It becomes 4 times. But 4 should be multiplied by 1, becomes 4. and multiplied by x is just minus 4x. On the right hand side, I multiply 8 by this, but before doing that, I simplify it in my head. It becomes 2 times. I multiply 2 here. It becomes 6x. And then this one I have to multiply 8 times 14, which is minus 112. Yes? And this is just a normal simple equation. So this one is minus x is equal to 6x is equal, minus 112. I move this 6x, becomes negative 6x with another negative x, becomes negative 7x is equal to minus 112. And then I divide everything by minus 7. And then hopefully I can simplify that. Do you see what is the answer? Is it 16? Yes?
Yes.
Yeah. So it is 16. So and x becomes 16. So that is the answer for this problem. So that number with that property was 16. So this is also something that there is only one more step. You need to read the text and be able to solve the problem. Okay? I want to pause recording the video and give you a little bit of time, because there is nothing that I can teach you here unless you read and understand it yourself. So I want to give you a little bit of time so that you can practice on these problems. Okay? And then after that I will solve them and the lesson for today is finished. If we have more time, you go back and work on yourself. Okay? I don't know, should I think it would be better if you give me a little bit of time for this one. And then I will, by the way, consecutive means one after the other. For example, 1, 2, and 3 are 3 consecutive numbers. But if I ask you, give me 3 consecutive odd numbers, you should say 1, 3, and 5. Or for example, 5, 7, and 9. These are 3 consecutive odd numbers. Yes? Okay, I will pause recording the video. I want to wait for you a little bit to solve these 2 problems. Then I will explain it to you, and then I will give you time to think about the next 2 problems. Okay? Okay. Now let us solve the second problem. The sum of 3 consecutive odd natural numbers is equal to 135. What are these numbers? Even if, by the way, if I give you this problem in the exam, even if you can guess the numbers correctly, this is not acceptable. So with these kind of questions, you have to set up an equation and solve that equation to motivate the answer. So here, I don't know, by reading this text, the text is not complicated, so the sum of 3 consecutive odd numbers is equal to x. We are supposed to find these numbers. Of course, this is important, listen to this. You might assign 3 different letters for these consecutive numbers, but that's not a wise decision. It is not wrong. I can say that let me call the first one x, the second one y, the third one z. But then how many variables I have brought into the problem? I have brought 3 variables in the problem, so I'm making the life harder for myself. But I really don't need to bring more than 1 variable, because I understand what is the meaning of the word consecutive odd numbers. So if I have my first number x, I don't need bring another variable for the second one, because the second one is, yes? X plus 2. And the third one is? X plus 4. X plus 4. This is acceptable. Another way you say that, no, I want to call the middle one x. No problems. I can call the middle one x, but this x and this x would be different. For example, you can say the middle one, I call it x. The previous one would be x minus 2, and the next one would be x plus 2. I myself prefer this method. You will see why this is easier to cope with the problem. But let me just clean that one for the time being. This is probably for you the most natural way of starting. I call the first one in my list x. The second one, instead of giving it a new name, I know that this is 2 units more, and this would be 2 units more than this one, because they are supposed to be 3 consecutive odd numbers. But what I know that the sum of these 3 numbers is supposed to be equal to 135. So that is the equation that you have to set up and then solve it. But this is even simpler than the previous one. X plus x plus x is 3x. And then 2 plus 4 is 6, is equal to 135. By the way, I forgot to mention here, you need to answer, because they have asked you what the number is. You would say that the number is 16, okay? This you need to write. I forgot to write it. The number is 16. Okay, when you got x is equal to 16, you need to answer the problem. Okay, so here, if I want to continue, I move 6 to the right. It becomes 3x is equal to 135 minus 6 is how much? 129. And then what x is 129 divided by 3, which is?
63.
No, 43. Yes? This is x. But be careful, if you stop here, even though you have done everything right, but this is not complete, because the question asks you, what are these numbers? So you need to write this down. The numbers are?
43, 41.
No, 43,
45,
45, and 47.
Oh, you did the other method.
Yes. So this is extremely important. You need to write this down after finding the answers.
Yes. This consecutive, or can we confuse why we have +2 and +4?
No, consecutive odd numbers means exactly differing by 2.
Oh, yeah, no, I get it.
But you are right. Consecutive means one after the other in a sequence.
Yeah,
Yes?
okay, yeah.
But because I have mentioned odd numbers, it means consecutive. Okay.
We're consecutive even though.
So here I want to clean it, but I want to solve it in a different way. So do you remember I told you that is up to you. I chose the first one to be x, but let me change my color. This time let me consider the middle one to be x. The people who are actually solving harder problems, you need to remember this trick. Sometimes it is valuable. So what would be the next one? X plus 2. What would be the previous one? X minus 2. This is better than this one because this is more symmetric. Why is that? Now the sum of these 3 numbers is supposed to be 135. But the good point is that because of symmetry, this extra number goes away, and then I have x plus x is 3x is equal to 135. But the answer is what? This one divided by 3 is 45. And this is not surprising because this time x is the middle number. But again, the answer that you gain is actually the same thing. So you need to write the numbers are, yes. So the middle one is 45. So the previous one is 43 and the next one would be 47. So you see that the final answer that you get and this one are the same, but this is a little bit, this was so simple that you don't feel the difference, but this one is algebraically simpler to manipulate. Yes? Any questions here? Okay, let us go to this question. A father and his son are 38 and 8 years respectively. How many years later is the father's age 3 times his son's age? Okay? Now I can clean this part. We don't need this anymore. Okay, so how do we solve this problem? Here I have a father and a son, 38 and 8 years right now. How many years later? You see, the question is asking you about how many years later. So this means take x to be that. So let x be, I don't know, the missing years that we are looking for. So you see, by reading the text, you need to have an unknown, so you give it a name. So here, by reading this text, it is immediately clear that the unknown that I am looking is the number of ages, that after that, the father's age becomes 3 times his son's age. Okay, now can you help me to set up my equation? How should I set up the equation? Yes? Good.
I wrote 8 plus x in paragraphs times 3 equals to 38 plus x.
Yeah, thank you very much. Because after x years, the father's age is right now 38. After x years, the father's age would be this. Yes? And the son's age would be this. Let me write it in this way. The son's age would be this, and the father's age would be this, after x years. Yes? But then, after x years, what is supposed to happen? Father's age is supposed to be 3 times his son's age. So it means that if I multiply this by 3, this is equal to that. Yeah, as simple as that. Just you read the text and you set up an equation and try to solve that. Is that understandable for everyone why this equation is correct? Yes? Are you happy, Carmen?
Yes.
Yeah, okay. So, 3 times 8 is 24, and then plus 3x is equal to 38 plus x. Then what I need to do, I have 3x here, I move x to the left, I have 38 here, I move 24 to the right. 3x minus x is 2x, and then it's how much? 14, yes? Oh, sorry. Yeah, that's correct, 14. And then x becomes 7. But you do not stop here. You need to write answer. 7 years later, this happens. Okay, something like this. And is that right? Let us check. What would be the age of the person, of the son after 7 years? It would be 15. And what would be the age of the father after 7 years? It would be 45. And it is clear that at that age, 45 is 3 times larger than 15. Yes? So that was correct. Any questions? Yes or no?
No.
Okay, so I will give you 4 or 5 minutes, yeah, I think a little bit around that, so you can work on these 2 problems again. Then we solve this, we are done for today.
We're done for today.
Okay, so let us now finish these 2 problems. So Eric has 1,000, or is it 10,000? Yeah, it's 10,000 crowns, and then Sarah has 12,000. Eric saves 2,000 crowns every day, but Sarah saves 1,500 every day. Okay, after how many days do they have the same amount of saved money? So what is missing here? By reading the text, you immediately understand the number of days is actually missing. So it's better to explain this. You would say let x be the number of days required by the problem. Something like that. Okay, and then you want to see how many days should pass so that Eric's money and Sarah's money are exactly the same. So how should I set up the equation? Anyone else? Not from this side? Yes?
I wrote 10,000 plus 2,000x equals 12,000 plus 1,500x.
Exactly. Yes? Because the money that Eric has is 10,000. Yes? And each day he is saving 2,000. How many days has elapsed? Supposedly x days. So it becomes 2,000 times x. This is the money that Eric saves during these x days. And he has an initial money. So the money at the end of that x days is this amount. Yes? And something similar for Sarah. Yes? Sarah starts from which money? 12,000. But this every day she only saves 1,500. So 1,500 times X is the money she saves during this period, and she has this initial money. And then we are interested to see when these two amounts of money are the same. Yes? But this is also good to know. So far, I told you how to solve equations with fractions. I never talked about how to solve equations with big numbers. So in those equations, we multiply to make it simpler. But here we can divide to make it simpler. Yes? Because immediately you see that, for example, I can divide everything by 100. It doesn't matter, you can start, I just want to teach you this. Of course, you can start solving the equation immediately, but don't get used to this way of solving the problems if you can simplify the equation first. So here I divide everything by 100. This becomes 100. This becomes only 20x. And then this becomes 120. And then this becomes 15x. This problem is not hard. Even if you don't do this, it doesn't matter. But I think it's better to get used to this way of thinking. So now I have 20x. I moved 15x to the left. I have 120 here. I move 100 to the right. So this becomes 5x, and the right-hand side becomes 20, and when I divide is 4. Yes? But you need to write the answer. After 4 days, they have the same amount of money. They will have the same amount of money. This you need to write in the exam. This is your calculation, but after the calculation you need to answer the problem. And here we learned that dividing by 100 is better because it makes the numbers smaller, even though these numbers are not that big, because you see that if I move this to the left, it becomes 2,000 minus that, becomes 500. And then if I move that one, it becomes 2,000. 2,000 by 500 is again 4. It's not that hard, but you need to get used to this way of thinking. Yes?
What level is this problem? Is it like an E level, A level, what?
I don't know exactly. I haven't organized them. Yes, but probably this is not E, this is not A. So probably this is C level. It's not the simplest one. It is not the hardest. Okay. So now let us go to the last problem for today. Eric's money is 5 times John's money. If John borrows 1,500 from Eric, then Eric's money will be only 2 times John's money. How much money does each of them originally have? Okay, so how can we set up the problem? So how did you set up this problem? This time, Ali, yes?
We can write like, let John's money be X.
Let me write. So let me write. Let X be John's money. Originally, yes? Okay, then?
Then we know that John's money or Eric's money is 5 times higher. Or 5
Yes.
5 times John's money, so
yes.
we write 5.
So what happens? Eric's money will be
5 times.
Will be 5x. Yes.
Yes.
Okay. So far so good. Yes.
Then John borrows 1,500, so we write 5x minus 1,500.
5x minus, because the money Eric has is 5x now. He actually lends how much? 1,500.
Yes.
And then what happens suddenly?
Suddenly, John's money is 2 times or 1/2 of Eric's money, or Eric's money is 2 times higher.
So Here, I think the other way around, wasn't it easier? So you wrote that X is John's money. Yes, that's good. Eric's money, according to the problem, is 5 times John's money. So Eric's money, that's also okay. But now John borrows 1,500. So it means that the money that John has now is X plus 15, yes?
Yes.
This is the money that John's have right now. Then it becomes how much? So if I multiply this by 2, it becomes the it becomes the Eric's money. But Eric's money after this one. I don't know, I couldn't explain it right, but this equation is correct. Yes, let me just again tell you what happens. So this is according to Ali is John's money. John's original money. Yes? So here is John and here is Eric. So if John's money at the time being is X, according to the problem, Eric's money is 5X, 5 times large. But now what happens? Eric actually sent 1,500 to John. So after 1,500 is going here, then what happens? John's money becomes this money. Eric will lose actually 1,500. Yes? Now this is after this payment is done. Yes? And now what, according to the problem, this time Eric's money is no longer 5 times larger, it is only 2 times larger. So this Eric's money is equal to 2 times this one. And that's the equation that I have written here. Yes, is that understandable? Let me explain it again because I see doubtful faces. So here, so let me write John here and let me write Eric. According to Ali, X is the money of John at the moment, originally, before this transfer has been done. Okay, so if John's money is X, according to the problem, Eric's money is 5 times John's money. So at the moment, the money for Eric would be 5X. Yes, is that understandable up to this sentence? Yes, and now, if John borrows 1,500 from Eric, what happens? If John borrows 1,500 from Eric, his money will increase to this money plus 1,500, but Eric will lose 1,500. Yes?
Yes.
And now read the rest of the problem. The Eric's money will be only 2 times John's money. So Eric's money will be 2 times John's money. So this becomes equal to 2 times John's money. And that's the equation I have written there. And then the rest of the problem is just simply solve this equation and answer the problem. So you see the hard part in these problems is actually setting up the equation. Okay, so if I solve that equation, I multiply it by 2, it becomes 2x. I don't multiply, the 2 is multiplied inside. So it becomes 2x plus 3,000. On the right hand side, I will have 5x minus 1,500. I move to 5x to the left. I move, so minus 1,500 is already there. I move this one to the left. It becomes, to the right, it becomes negative. And then this one is minus 3x. Minus 1,500 minus 3,000 minus 4,500. And I divide by minus 3, it becomes positive this number. So here, by the way, I don't know, I was a little bit careless. In the previous problem, I also have to write the units. Be careful. I don't know why I forgot about the units. Because there is a unit for this unknown here. Okay, so how should I answer? How much money does each of them originally have? So what you say? This is John's money. John originally has 1,500 crowns, and Eric has how much? Originally 5 times this number. Yes, so if you multiply that, 7,500. This you have to. And the other problem I also forgot, when I calculated x, I need to write the units, because sometimes the number that you are looking for has a unit. You have to express the unit in the answer, and that's a have to. Okay, thank you very much. So I think it's a good stop. So I will write on this Google Classroom which page on the book is related to this topic. Yes. Thank you very much.